So can you see the web browser with the application examples and my terminal?
I can see it, yes.
Yeah, I can see.
Good, good. So let me start with this quiz. So so there are some questions, yeah, to know something about, yes, the software that you will use, and also where should I start? So we will have, let's say, 5 minutes for that. Okay, we have some responses. I can see more now. Yes. So, okay, we'll be closing the poll. Let me see if I share the results because there are not so many people, right? So what it can help me to see what was the answers. So let me, yeah, it's enough. So this is the results, yeah. So interesting. And it seems that some people have run the software previously in an HPC center, and also, so half of the people knows that the software that they are targeting uh, can run in parallel mode. Birgitte has mentioned this previously about the GPUs. Also, the 70% of the people know that the software can run on GPUs. And yeah, people expect that the software run more efficiently in an HPC center. And yeah, this is a bit tricky if one adds more computing power, right? Uh, it doesn't mean that you will always get faster results, right? It depends on the application and how it was programmed. This is interesting. Why I cannot see? Okay, I will stop sharing this. I cannot see the results myself. Okay, I can see now the results. Sorry, Zoom asked me to log into this platform again, although I already signed in.
I think Zoom has a problem. I
Yeah,
had to sign in 4 times this
yeah,
morning.
that's another very very good too. So, but well, this is what I wanted to show you. Excuse me. Then these are the applications that you want to target, right? And this is the results of if you have used the software previously in an HPC center, right? If you know that this software can run in parallel mode, and so on. This is what I mentioned previously. So but we will focus on this part right now. So you can see that some people want to run in Matlab. This software, I haven't tried that, yes, but we mentioned how to run applications in general, so you can have also an idea of how to run that, and if it is installed in Kebnekaise, then you can try that, and if this is not possible from the first try, you can write a ticket to the support, right? So we will cover the most common software that is installed on Kebnekaise, and also some software that I try myself. We will try Matlab, R, and this one, which is a bit new for me, which is CryoSPARC, right? Yeah, so let me go to the material. The material is the website that Birgitte has been talking about. And it is in the last section. And here you can see the application examples. Yeah. And here I collected several exercises and some description of the most common packages that I run on HPC 2N. And here, for instance, I start with some kind of base practices or topics that could be very useful for you, right? When you are using our machine, Kebnekaise, or even in any other cluster, right? That has a similar system like the ones in NICE, right? So the first thing is, Birgitte mentioned that previously, well, it was in the Linux course for the ones that attended the Linux course, right? But otherwise, this is a good practice, right? Use your project directory instead of the home directory. So remember that the home directory has a limited storage space. So for your production runs, try your project directory that it has some name like this one, as Brigitte mentioned, Pro no backup and some number here. This is the default name, but if you gave it as some specific name in your application, then you should put it here. And here you should have a much larger space. The second recommendation is to create a soft link to your project directory. Right? It's very convenient, and several packages rely on the home path. So the software will look first to the home directory, and it will not take this path, right, straight away. So if you want to have this path, then you will need to search for it across the tree, right, in your directory. And it is not that convenient because first you need to locate where is the root directory, then the PROI, then go to backup and so on. So but if you create a soft link, then the programs most of the time will look for this home, and you will get quickly to this folder, right? So in the soft link, you use the command ln -s, this name of your project, And then you can choose a name that you want, right? And it will be very convenient. Yeah. Also, because you will be using several cores and also with some memory that is not available on your laptop, for instance. We have the large memory nodes, for instance, where you can get more resources than in a laptop, right? So then it's a good idea to monitor what your application is doing. And also, Birgitte mentioned that previously there is a command called job usage, right? That you can get on in the Kebnekaise terminal, and it gets as an argument the job ID. That is a number that you get when you submit your job with the sbatch command. So if you want to see this number, then you can type this command sq minus u and your username. Or Brigitte mentioned as well that if you type sq dash dash me, then it will show you the jobs that you have in the queue, right? So then here in the job ID section, you will see a number that you can use in job usage. Then you will get a URL that you can copy and then paste in your local browser, and it will show you the statistics about the usage of the resources. Here, for instance, imagine that you ask for two nodes and GPUs and a large memory, yeah? But if you go to the GPU section, then you see that you are not using the GPUs at all, right? So it means that something is happening. If you expect the software to be using GPUs, or maybe you requested two nodes with 56 cores, for instance, and that would be the 100%, right? But if you use only 10% and you're expecting to use everything 100%, then something is also happening. Also, if you are developing a code, for instance, and at some point in the memory usage, you start seeing that the memory is increasing, then it's a sign that the program most likely is leaking some memory. You can detect it. So it's a good idea to monitor resources when you are in an HPC cluster. And in HPC2N, we have this tool called job usage that you can use. Okay, so after these general recommendations, we can start with Matlab. So first of all, Matlab is available through the menu bar. So for instance, if you're using ThinLink, which is a recommended way to use Matlab, because in this way you will get Matlab GUI to work faster, right? Otherwise, you will see some delays in the Matlab GUI. Yeah. So how to get it? You go to the menu here. Notice that I made some modifications to my graphical interface, right? Because I ask it to hide if I am not using the menu bar so that I get more space, right? Also, you are seeing here that I have some colors in the terminal. It is because I modified some parameters in the bash RC file, right? But it's exactly the same. So if you go to the menu, yeah, so then you go to Let me see, programming. Yes, if you go to programming, then you will see that there are several versions of MATLAB installed. Yeah? So you can get MATLAB in this way, right, by clicking on this. But is- if you get MATLAB in this way, then it will not recognize the working directory. So at some point, it will ask you to set the working directory. And what is the working directory? Where is the directory where you have your scripts? So Brigitte asked you to copy the intro course material. You can clone it, and in the exercises folder, you will see that I have several subfolders, right? And here there is one for MATLAB. So if you go to MATLAB, then you will see several examples. So then this part it will not be recognized by MATLAB immediately, right? And then you will need to set the working directory manually once a MATLAB asks you for that. So and then how can I start MATLAB? Yes, we can search for MATLAB here on the command line with a command ML spider. Okay, I need to start with the M capital, right? And you can see that there are several versions of MATLAB. For instance, I can choose this one. Yeah. Then I can search for the dependencies, ML Spider, and then use this version, that is the one that I am targeting. And it tells you that this module can be loaded directly. Yes, and it doesn't need any requirement. So that's why I can load it. It means ML means module load. And then I load MATLAB in this way. So now MATLAB should be available. So then I need to start MATLAB, and it needs to be started in some particular way. So if you go to this link here, you will see more information about MATLAB, right? And there are some initial steps that you need to follow. So first of all, we can start MATLAB with this command here. And it means that MATLAB will start with a single, in a single thread mode, right? So otherwise, if you start MATLAB without this command, it will try to use all the resources in the machine, right? And remember that now we are sitting in the login node, and we are not supposed to run on all the cores that are available, because there are other users that are using the system at the same time. So that's why we instruct Matlab to start with a single thread, which means a single core in this way. And then it starts. So notice that here I don't see any delay in this graphical interface, but if you use or restart MATLAB through SSH, you will see that it runs a bit slower. This is my impression. So now you see that Matlab, because I studied it from the terminal, now Matlab recognizes that the subfolders are these ones, GPU, serial, and so on. But if you start that from the menu, then you will need to locate this long path here, right? Until you arrive to these subfolders. That's why for me, at least, it's more convenient to start Matlab on the directory where I am working. So before using Matlab in its full potential, you need to do some initial configuration, right? So you go to this link here, you click on it, you will see some configurations that you need to follow. First of all, you need to configure the cluster, right? With this command. So for instance, you start here the command config. Notice here that I am in the command window, config cluster, and it starts some configuration. So it tells you something. A default cluster is set to Kebnekaise, and here there are some options that you need to set. Yeah, and we can start with that. If you are following this, then you can copy and paste this part. CPAR cluster. Yeah, this only creates a file handler to the cluster, and then you can start doing some initialization. Yeah? And here in the account name, it means the project you are part of. Yeah. For instance, in the present case, because we are in this course, it's HPC2N 2024 and 84. But after this course, you can modify this. So it means that after this course, if you're part of another project, then you can do this configuration again, right? So this is the account name. In this case, for this whole time, I will choose only 5 minutes, or let me ask for 25, for instance, 25 minutes. And then I can save the profile. And I will add something additional. If you look at the configuration of Matlab, I will use this property. Yes, I will copy that and paste it here. With these additional properties, additional submit the arguments, and I will use only one node, which you don't need to. Yes, but it could make the things easier because I will request only one node. But if you will use several nodes, you shouldn't use this flag. And then I can save the profile with this flag here. And notice that if you are going to use GPUs, yeah, then you need to add some additional variables. Yeah. For instance, here, if you will use one GPU card, then you will need to add these two flags. Yeah. Notice that if the job is not using GPUs, but if you set these variables and you don't change that, right? So the job will allocate a node that contains the GPUs. So you will be allocating GPU resources, although you are not using GPUs at all. So, but if you know that for that particular job, you will be using the GPUs, then you could start this config cluster again and set these variables here. So I know that for some jobs, I will use now this V100, and that's why I will set this to V100, and then this to 1. And then after that, I can save the profile. Yeah. So if you're curious what happened here, so you can go to this section in home, and then go to parallel, and then click on this button here, create and manage cluster, and then you will see, I can see some comment or, okay, okay, yes. And then you will see that this cluster was created, which is called Kebnekaise, and it is default one. And if you go to this part here, then you will see the values that we set, including the project ID, and also the additional argument, the type of the GPU, and this number that is set here, GPUs per node, and the wall time. Yeah. So this is the cluster that we set, and we can try the validation. And let's see, the validation step is something that you can try when you create or configure the cluster, right? And it tells you that if it is running well, and if the standard test from Matlab passed. And for this, I will use a small number of workers, in this case 4. And let's see if it works. I can take this. So it seems that the first test passed. And if you check the job queue with the command sq dash dash me, you will see that Matlab sent a job here. Yeah? And it is the status is resources. Is looking for resources. So, but most likely for this job, it will take some time, because the Skylake nodes are not or are fully occupied at the moment. So we have a reservation on the L40s, right, Brigitte?
Yes, we do.
Okay, so let me stop this validation, and let's try again this CPAR cluster, and then the project, whole time, the additional argument, and oops, is this one, L40s, GPUs per node, and save the profile. So notice here that I change the GPU card from V100 and L40s. And I will go to the cluster manager, check the properties if they are okay. Okay, so now go to the validation and see. So now I can go to the queue and see that it seems to be running because we have more L40s, and you can see here that it's a job ID. Let's see if the jobs are doing well. So the second test was passed. So this is I would say this is a good practice, right? To do the validation of the cluster, because sometimes you forget to write something or some flag that you use is not correct, and then you expect the job to run in the parallel mode or on the or on the compute nodes, but actually it doesn't run, right? Because this initial cluster was not well validated. So you see that 3 steps were passed, and this is the last one in the parallel pool. Yeah. So okay, so notice that here all the steps were okay. So the pass, and then we are ready to use this cluster for our either CPU jobs or GPU jobs, right? Because we added these GPU cards. But notice that, as I said before, if you use this cluster as it is, with these GPU cards added, then even though the job doesn't require the GPUs, the job will be allocated in a GPU node, and you will be charged in your project hours, right? So not, as Brigitte mentioned, right, not in terms of money, but in terms of project hours. Yes. So then if you don't need this, yes, remember that you can restart the cluster with this flag, and then set this to white spaces like this, right? So that the value is resetted. And then after doing that, save the profile. So then you will be in a safe mode and uh, taking care of your core hours in your project. Okay, these are some tools. I put this flow chart that it was adapted from Matlab. And notice that Matlab, it's efficient for doing different types of simulations, and they have many different tools, right, that allow you to do simulations in a very efficient manner. So here I put a question, right? So the first of all, if I feel or if I have some issues in my workflow, and notice here that it's essential to have this point. Your code or your initial code is giving you the correct results. Before trying any of these steps, right? So your code should be correct, right? Or giving some answer that you expect. So then, what is the issue? Do you need a faster processing, or maybe you are dealing with big data, or both, right? So if you need a faster processing, then Matlab has tools for profiling the code. It offers also some vectorization tools and built-in functions which are very fast. Yeah. After doing these initial steps, which still are in the single core or serial mode, right? After doing this, if you still have some issues with the performance of the code, or maybe you think that it could run faster using many cores instead of only one, yeah, you need to be prepared to change the paradigm of programming that you have been using up to this point with a serial code, right? And then once you change this paradigm, you can start parallelizing your code. So there are some options in Matlab for doing the parallelization in CPUs or in GPUs. If you're using CPUs, for instance, Matlab offers several functions like parv4, parv-eval, SPMD, right? Or if you're using GPUs, UPU array is your friend. So then you can start some parallelization, and this could be a loop, right? Where you can even combine the things, right? And use some parts for CPUs or GPUs and integrate it until you get some performance that you want. And then if you want to use a cluster, then you can do this through the batch command that is offered by Matlab. And then finally you get your results. Otherwise, if you're targeting big data, so you don't care so much about the performance on running on many cores, but you want to analyze large amounts of data, then you can go to these flow diagrams. Matlab offers you a distributed arrays, tall arrays, and also this workflow can be run on a cluster like a Kebnekaise. So Birgitte was in more detail in this part. So notice that Kebnekaise is now a hybrid, a highly hybrid. So we have different types of NVIDIA GPU nodes, right? And also AMD GPUs. And it's good for you if you have all this variety of GPUs available, because depending on the type of simulations, then you can get a more efficient simulation, right? Running that more efficiently. But at the same time, it needs some kind of mindfulness, I would say, in the sense that you need to see or to realize what is the node, or what is the hardware that you want to use to get an efficient simulation, right? Specifically, and that's why I choose here the L40s. This is because the L40s and the V100s are the most abundant up to now at HPC2N. So for instance, if you set your simulations for the A100, right? So maybe they run faster than on the V100 or L40s, but remember that currently we have a small number of A100s and A6000 and so on. So that's why you need to be aware of this thing. But you are in the safe mode, I would say, if you are targeting the V100 or the L40s because they are the most abundant. So this was mentioned also previously, but Matlab, as you can see here, I have the GUI running on the login node, and it's easier, or it's easy for me, for instance, to go to the mode where I can simply run my code here, right, on the login node. But remember that this shouldn't be done, and all the jobs that you want to do for your production and that are heavy, right? Especially if they are parallel jobs, then they must run on the compute nodes. And for that, you need to use the batch mode. So here there are some exercises that I wrote, right? And that you can start. So here, for instance, in the folder serial, if you go to this folder serial, yeah, you will see 3 files. Funct m is a simple function, as you can see here, and it just computes some Fourier transform, right, of a matrix defined here, and then it prints out some files. Then we have the submit script, which is here. And notice here that I call the file handler that I defined previously, and now we are in the safe mode because we know that this cluster was set properly. And there is also an alternative to submitting this job through the Matlab interface. So Matlab is well uh, coupled to the Slurm system, and that's why you can submit the job directly from the Matlab GUI instead of using the batch scripts that Birgitte mentioned previously. But also, if you want to use a batch script, there is also the possibility of doing that. Yes. So maybe you don't want to interact so much with the graphical interface. You don't need to run or to plot anything, but you only want to get the data, right? To analyze it later on. So maybe in that case, you can submit the job through a batch script that Birgitte mentioned previously, and this is an alternative to this submit file, right? So notice that essentially is taking the same arguments, right? Just a single core, some arguments for the function here, and then this will be queued in SROM that we have set. So yes, this is an exercise that you can do, and this is the initial one. There are also some exercises for MATLAB Parallel, and these are included in 2 folders here. There is one called Par4, and this is an example here, a simple one, just to execute a loop right, in parallel mode. So if we want to run this loop in serial mode, so we use only the for instruction, right? But Matlab offers the option par4 to make the for loop parallel, or to be aware of the parallel architecture of the machine. So this is the parallel job, a parallel example, and this is a submit file that you can work out. So start with the file handler, right? And then here you need to choose some number of workers. Yeah. Then you will wait for the results, and then you will fetch the output. So how do you run it? So you click on this button here, and notice that even though you are clicking on the button here on the login node, this job will be sent to the compute node. So you will be computing this node on this node, but in a compute node, which is good for all the users that are logged into this node here. There is also a folder called SPMD, and this is another example that it's here. And this is another way to start Matlab, and this is more interactive, right? Because in this case, you start a par pool, and all the things that you start running will be aware of the parallel cluster. For instance, here I start a par pool with 4 workers, and there are some instructions that are aware of the parallel architecture using 4 workers, and this will be computed in this par pool. And again, not in the login node, but they are running on a compute node. Yeah? So besides this, there are some things that are performed in parallel mode. There is some simple integration, again with SPMD, and SPMD is aware of the 4 workers that are defined here, right? And finally, you print out the results, and you delete the cluster, right? Which was created here. So this is another way to run a parallel job in Matlab, right? Instead of submitting everything or each function to the queue, so you can simply start the par pool and do all the things that you want to do in parallel mode by using this defined cluster. And only when you delete the cluster, then this job will end in the compute node. So the third exercise is a MATLAB GPU job. And here there is an example for how to compute a simple Mandelbrot set. So here there are some parameters for setting the Mandelbrot, for computing the Mandelbrot, the maximum number of iterations, and so on. And this part will be computed in serial mode, because you see here that I'm using for loop. It will run on a serial mode, and also on the CPUs. Yeah. And then you will get a picture, and it will tell you the number of seconds that it takes to compute this on the CPUs. And the submit script is here. Yes. So you can simply click on this. If your cluster was properly set, then it will run on in the GPU. And then there is the same example here, but for GPUs. And notice that the only thing that we modify here was that instead of using the arrays, where it was here, This arrays here on the CPU. So we are using now the so-called GPU array. Yeah. So it means that this data is sent to the GPUs, and then it is enough to tell MATLAB I want this procedure to run on the GPUs. Yeah. So that as simple as that. So, but yes, for getting started with the GPUs, this is very convenient because you don't need to make large modifications to your code, right? And it will offer you an a very initial, nice initial improvement, right? So there are further options to use GPUs in MATLAB. And finally, you will get some picture as well with some timings. Yeah, and this is the script that you can use. And notice here that I set this to V100, right? But we will be using the L40s for this simulation. This part is um, good to be aware of. So I previously mentioned that you can configure your cluster, right? So that it uses some type of GPUs. And then if you want to use another type of GPUs, as I did here in the Spark cluster case, so then if you want to use another GPUs, you need to reconfigure the cluster by running again the config cluster command, and then set this property to the proper GPU and the number of GPUs per node and so on, right? This is one way to do that. But maybe another thing that you can do is that you can configure the cluster without any GPU, right? And only in this part, in the submit file, right? When you know that you will be targeting, for instance, the L40s, yeah, you will change this part. And then Matlab will recognize that you want now an L40 GPU. So maybe also later on you decide that you don't want this number or you don't want the GPUs, and you can set it to empty string, and this also to the empty string, right? So then you will delete these values that you have set previously, and you don't need to reconfigure the cluster. But it depends on your needs. And if you will be heavily using the GPUs, then it's a good idea to set the parameters once for all, right? So it's up to you. But this is one way to avoid the recompiling, the compilation of the cluster. Okay, so I think this was everything from MATLAB. Is there any questions at this point? Anything else you want to know about MATLAB or these examples, exercises? If not, then I can continue to the next software that you want to uh, hear about. I will say I don't want to change the input. Yeah. So then I can go to the next software, and maybe I can talk about the CryoSPARC, right? Which is new. or well, is this was recently installed on Kebnekaise. And here is some short description on CryoSPARC. This version is installed on Kebnekaise as a module. And there is some first-time configuration that you need to follow, right? Including, for instance, the creation of a license. So you need to do this through the website of CryoSPARC. It takes about 1 working day of processing, where they send you some a key that you need to add to a file called .cryospark-license in your home directory. And this is the first line of this file. In the second file, they ask you to write your email address. Yeah? So something that you can do for CryoSPARC is the following. In your project, yes, so you can modify here to the current project, or maybe you already have a project, right? And for the project that we are using here in the introductory course, it's a good idea to create a subfolder with your username so that you don't overwrite or your files are not overwritten by the other participants. Yeah. So but in this case, I just said this in a general manner, and then I created a folder called CryoSPARC. Yeah, but you can call it as you want. Yeah. And then you can move to this folder, and this is what I did here. I created a folder and moved to this folder. And then I ask you here to download and copy these files called the lane files that are located here, right? So you click on this button here, you will see the files that I mentioned. And then you can get these files from this folder or from this repository, and then you can copy these files into your directory. So there are different ways to do that. Yeah, let me see if I did it. No. There are different ways to do that, and one of them is as follows. So either you clone the repository. If you clone the repository, then you will get these files because they are already the tar files in the exercises folder. If you go to exercises and you go to CryoSPARC, you will see that we put these tar files already there. Yeah, so they are already there. So I think it's it's a good idea if you start from this folder instead of another CryoSPARC folder, because the tar files are already there. So but in my case, I already had this folder, and that's why I would need to fetch these files. So yes, once you have these files, yes, and let me know if you are not you're not able to get the lane files. So they should be in the folders directory in the exercises and CryoSPARC. And then you can untar them with this command. Yeah. And for instance, I put this example here with tar, oops, tar minus xvf, and then lane CPU and the tar. Yeah. So as you can do this for all of these lane folders. And they will allow you to use the CPUs, A100s, H100s, and so on. These are all the GPUs, and there is also a lane for the CPUs. So once you do this, yes, and you get the untar folders, then you can go to the lane that you are targeting, and then modify the file called cluster underscore sh. And by the way, these folders were kindly provided by Andre Graca, who was a member of the chemistry department, and I adapted them and to some of the nodes that are available on Kebnekaise. So here, this is how it looks. You need to modify a little bit this cluster script.sh file. Here I set the time to 20 minutes, but of course you need to extend it to even days if you need it, right? If your processing takes a long time. And this is just a name that it will be taken from CryoSPARC. It will start with CryoSPARC, and then the project UID and the job UID. And these are variables that are native to CryoSPARC. They will automatically be set. Here is the project. In this case, is the present one for the intercourse. And this was mentioned previously by Brigitte. There are some constraints that you can add. And because CryoSPARC is installed in all nodes, then you can remove this because you won't have any constraint. But if you want to target only some CPU, then you can leave only the CPUs that you want, right? This is also another flag that you can set the output file and error files, and also some number of CPUs, which is also taken by CryoSPARC automatically. And this is how CryoSPARC will run. This is some command that should be there. It's a variable from CryoSPARC. Okay, that's enough for CPUs. You can also do that for the for all the GPUs. And this should be done just the first time that you set the folder where you will work. Yeah? So you can change the variables here as well, and so on, and do the similar things for these folders. So the lanes will be recognized by CryoSPARC when it starts running. And then here, first, we will start the process. So first of all, load the CryoSPARC modules. So let me first purge. This is also a good practice to purge before doing anything else. And then I will look for CryoSPARC. And you will see that this module is installed and it has these dependencies. So I will load them. So now that we have loaded the modules, yes, that are needed, then we can start CryoSPARC, and you start it with CryoSPARC. CryoSPARC start. So if this is the first time that you initialize a folder, it will ask you some questions. Huh? It will ask you if you want to continue with this directory and you want to do the initial settings, right? But I did it already. And also, the first time that you run CryoSPARC, you can run CryoSPARC list users, yes? And then you can reset the password with something that you want. Here you can choose a password and use the same email that you wrote on the license file. And these are needed because here, when you start CryoSPARC, it will ask you for some username and some password. So what you can do now is you can start a CryoSPARC, as I'm doing it here. So it tells me some information about this folder. It was previously initialized. That's why they are not asking me about the initialization. And here you can see that I got the URLs, right? So I can copy this one, for instance, this one or this one, will be the same in the present case. I will choose this one. I will copy this URL. Then I will go to some browser on the menu bar and then go to Internet and Firefox. And then here I will paste the URL, and you can see that now here is CryoSPARC running. It didn't ask me for this information because I was already logged in. So then you can see here the interface, right? And I follow the following tutorial that is from the CryoSPARC community, yes. And here you can see the steps that you can follow. The first steps only require CPUs, but this step here, motion correction, it needs some GPUs, and then you can set or use them based on the lanes that you created. For instance, here I did the motion correction in this part, as you can see here. And here, if I clear the job, for instance, then I can send the job, queue the job, and it asks me where do you want to queue the job. Let me see, build job, queue a job, and here I can set the lane that I want. Yeah. So notice here that CryoSPARC tells me that it needs or it suggests 6 CPU cores and 1 GPU. So GPUs are suitable for this type of job. Then I can use this one or L40s. Remember that these are the most abundant in HPC2N. And yes, you can try it. Okay, so some things that you can also know is that we use this command CryoSPARC instead of the suggested CryoSPARC CM command. If you go to the tutorial, you will see that they use this one, but the one that is supported on Kebnekaise is CryoSPARC C. Yeah. So this is the step where I use the GPUs, right? And here you can select the lanes and it tells you the resources or the optimal resources that are needed for this job. Yeah? So then I can log out from this. Let me see where I can log out here. I will log out. And then let me close this. And then remember to stop CryoSPARC. because otherwise it keeps running on the login node. Yeah? Here is some additional information on Berzelius and NSC documentation. And notice that these are not the same machines as Kebnekaise, but they are very similar. And something or more ideas you can get from them. So, yeah, is there any question about this software?
So with the lanes, did you say it actually suggests which one to use in each case for each job?
I would say if you want to get the jobs running faster, you can select the L40s because they are the most abundant, yeah.
Okay.
But if you have something more specific, like maybe the number of cores or the memory, then you could target another jobs. Currently, the V100s are heavily used, but the L40s, they have also, some nodes available. So
Okay.
yeah. Okay, then I can go to a different software, and I will talk about the R, yes, for the R users that are interested on it. So the examples can be found also in the repository that you cloned previously, and they are in the exercises and R subfolder. You will see here all the examples or exercises that I prepared. So first of all, I will do an ML purge, the best practice here. And then here I wrote some a short description on R. So similarly to Matlab, R is available through the menu bar. Yeah. So if you go to the menu bar, as we did for Matlab, you will see that in the programming option, let me correct my mouse. In the programming option, R Studio is listed, right? So if you load this, then you will get R and R Studio, right? But similarly to the case of MATLAB, so it will start from the root directory. So if you need to work on some specific path, then you will need to set manually the working directory to where you have your scripts. That's why in my case I prefer to load RStudio from the path I'm working currently to get automatically the working directory. So how to access Matlab R, sorry, you type ML Spider that R, and you can see that there are several versions available. So then you can search for the dependencies, ML Spider, and I will choose this one, but you can choose the one you like. And here you set the requirements. You can use the pure CPU case, or you can use the CUDA aware version of MATLAB. So I can use this one. Then I load the modules. And here I can start RStudio. And then you can see that the R version that is recognized is the one that was loaded as a module, right? So here you also need to do some first time configuration only once, right? When you get started with some version of R. So first of all, R reads this folder here, environ.r environ, that is located in the home directory. So that's why you need to follow these steps the first time that you load the module, so that in the home directory you get this folder here with the R version that is available. For instance, in my case, let me see. You will see that I have several versions. Home, let me see, home. Interesting. Let me go to home. Okay. Well, so yes, the first time that you follow these steps, yes, you will be able to use the version of Matlab. So in my case, I haven't done it for the current version of R. Okay. So yes, try to follow these steps here and let me know if you have any issues with this. This will prepare your simulations to run the scripts with the version of R that you are targeting. And you should do this only once when you start using some version of R. This is some general recommendations and something that is common, or yes, it is a bit common when you are working in HPC. And this is a case of data duplication. And for instance, we use some parallel function. In this case, I use MC apply. Yes, it's just one of them. R has several functions to deal with parallel code, similar to Matlab. Yeah, and this example shows that you can get some data duplication when you use these parallel functions. And this is not crucial if the data that you are using is relatively small, but if you have a big data frame, for instance, and then you're employing several workers or cores, then you will multiply the required memory, and you can easily exceed the available memory per node without noticing it. So in this example, I'm using parallel and the PRIR packages. PRIR will allow you to monitor the memory that is allocated. And this is some script, yes, that is from R. So you need to check if you have installed parallel and PRIR. So otherwise, you can install it with the install packages functions in R. And then you can monitor the allocated memory, right? Here one defines the relatively large data frame, and notice that this is very simple. It's not large, it's still small, yeah? And it has only two entries, ID and value. And then you have some function, right? Where you take some index and you do some modification to the function, to the data frame, right? You do some a tiny modification to the data frame. So if you check the memory that it was used here compared to the initial one, you will see that nothing has changed considerably because you will be running initially the function in serial mode. If you run this function as it is, it will be in serial mode, right? And then you can get here some memory, the allocated memory in megabytes, right? So this is the serial case, but now if we try some parallel function like MC Lapply, yeah. So then we can set some number of cores, which are also called workers. And then we start the MC Lapply and execute the function by using 4 cores. And then you can get the size of the memory that was allocated also in megabyte and do a comparison to see that this process causes some data replication. Yeah. And it's because here, when you do this in serial mode, so R doesn't need to do several copies of the data. But in this case, because every worker has a copy of the initial data, then R needs to replicate all the data to avoid some conflicts. Yes, in that some workers overwrite the necessary data. Yeah. So there are unwanted duplications, and this is some common issue that I have noticed in some workflows, especially now with the machine learning and deep learning jobs, right? So you can call this example a memdup, for instance, and use this job here to run that. Yes, change the project name and also that should be enough. Yeah? Remember that R should be used only for lightweight tasks on the login nodes because there are several users, yes, on these nodes, yes, and otherwise they will see some delay. And here there are several exercises that are prepared for you, and these are the requirements that you need to follow. Yeah. So first of all, follow these instructions that I mentioned previously. There are some preparation steps, yes, that you need to follow here. And let me know if there is any issue in following these steps. Also, you need to install some packages. If you go to this website as well, in the instructions, you will see how to load, how to install your own packages here at the bottom. And these are the packages that we will be using, are MPI, do parallel, caret, mass, and so on. And this is a serial job in R. This is the script, and it only prints a hello world plus some values of the variable argv. Yeah? And to run this script, yes, you can use the batch job sjob here and run these two lines. The first of all, by running rcmd and then using R script. These are very similar commands. And the main difference, as you will notice, is that R script accepts some command line arguments, as I am giving here, yeah, 3.14. Also, there is an exercise called job arrays, yes, which allows you to run many copies of the same file, right, where some parameters are changed only. And this is an example. You can see here that the job ID variable gets its value from an slurm variable, which is called job ID. And also there is a task ID also set by slurm, right? And you can use these variables to tweak your own simulation. For instance, here I asked you about one situation where you need to change a single parameter, such as the temperature, and these are the values that are changed from 2 to 56 is Celsius. And you could use this task ID variable to run 28 simulations at the same time. Yeah? This is more advanced RMPI, and you need to know how to program in MPI here to take advantage of this parallelization scheme here with MPI. But if you know how to do that and you want to run it, here is the R example, and this is the bash script. You can also use do parallel, and in particular the for each function to run your code in parallel mode. Especially, for instance, if you are using for loops, yes, that execute many tasks, yes, that can be parallelized. You can get the idea here in the do parallel code. Here is an example taken from this website. Here you can get more information. And this is for the IRIS database. So here you set the database, right? And then you do some computation with this machine learning model. And you do this in serial mode, because here you use the for each function with the do flag, yeah? So this is the serial function that you can also run by using a for loop, yes? And this is something that many people do. They run this type of simulations in serial mode because they use for loops. But it's easy to go from here to a parallel mode where you use the same for each function, and then instead of do, you use do par, and then run this by using a cluster, right? First you set the cluster, register the cluster, execute the function in parallel mode, and finally you stop the cluster. This is an example, do parallel, and this is the way to run it with the batch job. So this is also a do parallel job, but this is a machine learning job, and it's more advanced, yeah. You can also here get some timings for the serial mode here, and also by using the parallel simulation with DuPar. And more advanced machine learning jobs here, and how to run this with this batch script. So let me know if you have any questions about these exercises or about the software that I talked today. So we will be here up to 17, right, Brigitte?
Yes, yes, we will. So if people want to try and
Yeah.
run any of the exercises, have questions, then please go ahead.